Straw in the Wind is the winning competition proposal for the Eco Home Pavilion in the City of London promoted by the London Festival of Architecture. Has been planned to be built as a temporary building in front of St. Paul's Cathedral, made from straw. The purpose of the pavilion is to raise awareness of bio-based material and to demonstrate that, for example, straw can be used as a construction material, with many properties and advantages over materials like concrete, bricks, and steel, and provide a carbon-neutral building. With straw filled into the timber frame structure, Mortsail Company provides this kind of prefabricated straw panel that can be directly used as a load-bearing walls or non-bearing walls. Straw in the Wind uses these panels to structure the pavilion, and through revolving the panels, it can open or close the walls, allowing people to pass through every side of the pavilion and making it a versatile space for a flexible future program. Despite all these relevant and important aspects of promoting bio-based materials, the pavilion does not discuss where the materials are coming from and how they are being produced. So we would like to ask, what does it take to produce these materials, and is it possible to produce them on site? To answer these questions, we started by analyzing the pavilion structure to understand the components that they are using. In order to have a further understanding of how the system works, we calculated the amount of material needed for this pavilion. This is the canopy, which consists of timber and recycled plastic sheets. Timber is about 1,344 kilograms and plastic is around 54 square meters. As for the housetop, the beams are all made from timber. Approximately 1,152 kilograms of timber is used in this part of the structure. Beneath the top, 4 timber posts support the ceiling, and all the surrounding walls are made of straw panels. In the panels, there are at least 1,280 kilograms of straws, and the timber frames weigh about 384 kilograms. Throughout the construction of the house, some non-bio-based material was still used. However, these materials are also treated in accordance with the principles of sustainable development and low carbon. The plastic sheets used on the roof are remade from recycled plastic products such as umbrellas and beverage bottles. The pedestal, scaffolding, and other items used in the foundation are also rented from specialized construction companies and returned after construction. For our project, we will focus on straw and what is needed for its production. The first picture illustrates what a wheat crop looks like. After harvesting and drying, we acquire the dry matter of the wheat, in which 51% of the weight belongs to the grain, 32% belongs to straw, 11% belongs to chaff, the rest 6% are leaves and dead shoots. According to existing statistics, in 1 hectare of land, you can harvest 18.4 tons of dry matter in 1 year, and 32% of them are what we know as straws. To be on the safe side, you can count on 25% to make up the loss through the transportation and selection. So that means we can acquire 4.6 tons of straw from 1 hectare of farming land. Each of the prefabricated straw panels in this project is 3,000 mm in height, 1,000 mm in width, and 350 mm in thickness, equivalent to 80 kilograms of straw. And this is another project we can learn from, called the Wakelins Farm. Wakelins Farm is a 22.5 hectare arable farm in Suffolk that has experimented with various agroforestry systems and collaborated with the Organic Research Center to collect data and promote sustainable agriculture. Alley cropping, also known as the hedgerow intercropping, is the planting of food, fodder, and special crops between rows of trees. It's a more extensive variant of intercropping or companion planting that takes place over a long period of time. Alley cropping has benefits for both people and the environment. It diversifies the farm's product output by allowing hardwood timber to be harvested in addition to food, generating cash flow and diversifying farm income. Secondly, alley cropping facilitates soil improvement by planting timber trees on the land that has been eroded or over-cultivated to produce lower yields of any crops. improving soil quality and converting marginal farmland into higher value woodland. Thirdly, the trees create a crop microclimate, reducing wind speed and contributing to the yield quality of crops in alleys. Fourthly, they help to enhance the biodiversity of farmland and improve the growing environment. At Wakelins, they have a total of 56 tree lines. Some are 12 meters apart, some are 15 meters apart, and some are 18 meters apart. Some tree lines are a mixture of walnut trees, apple trees, plum trees, and pear trees. Tree line 17 to 38 are a mixture of timber trees, cherry trees, and some apple trees. Tree line 39 to 45 are a mixture of apples, pears, plums, quince, peaches, apricots, medlars, and other fruit trees. Tree lines 46 to 56 are hazels on a median rotation carpet cycle for use in hinging, thatching, and the rest achieved for use in the biomass boiler to heat the Wakelins farmhouse. There were few flora and fauna in the initial site of Wakelins construction. More plants are commercial crops, and animals are mainly decomposers and low-level consumers. Continuously improve the biological richness by increasing the number of plant species. In the early stage of farming development, through human intervention, the biological chain can reach a richer state in a short period of time, and then let it continue to eliminate inferior species through natural development while attracting other predators. Throughout the years, Wakelins Farm has significantly improved the environment on its land, and even attracted some endangered bird species to visit. Using Wakelins as an inspiration to organize agroecological farming, we are going to select a piece of land where we can potentially plant and harvest straw to build the Straw in the Wind pavilion, but also to introduce agroecology so the pavilion can be provided with materials and products for its future program by an agroecological landscape. We selected this piece of land within the Queen Elizabeth Olympic Park in the east of central London, used for the 2012 London Olympics, and is now a part of the parklands. The land marked in red is today a rarely used lawn within the park, with little or no vegetation, with an interesting location next to the Here East, a hub of creative and fabrication industry from where we could draw some synergies in the future. If we move on to our site, we noticed the soil in the site was artificially purified for the 2012 Olympic Games, and there are still some deficiency in the soil level and some trace elements. So the first thing to do is to focus on the restoring soil fertility and healing the land. And then is to add some species with high resistance to pollution on the basis of the last step. Ideally, the soil will be improved for wheat growth after these steps. We imitate the planting pattern of Wakelins Farm, farming wheat in the interval of trees and shrubs. Finally, more ornament plants will be added, while enriching the biodiversity of the site. After harvesting of wheat, the straw can be used to build a pavilion on the site. The land will be used for sharing by the local residents. It can be the city farm, a public park, and also a good exhibition for the straw pavilion. So the mission for the first year is healing the land. We use several nitrogen fixation plants, Cytisus scoparivus, Ulus europaeus, and Tifolium repens. Nitrogen for plants is vital to the success of farming and gardening. This kind of plant can absorb nitrogen from the air, turn it into nitrogen compounds, and store them in their roots. They are creating a green warehouse. While they are growing, they release very little nitrogen into the soil. But when they have done growing and die, their decomposition releases the stored nitrogen compounds and increase the total nitrogen in the soil. Their death makes nitrogen available for the plants later on. Then in the second year, we can have the wheat crops and tree planted. The total wheat planting area set on the site is 3,600 square meters, equivalent to 0.36 hectares. After calculation, This weed can provide us with approximately 1,656 kilograms of straw materials at the end of this year. As we just mentioned, in the Straw in the Wind project, the pavilion uses 1,280 kilograms of straw materials. This means the land we farm in a single production cycle can provide enough straw materials for this pavilion. In addition to weeds, some ornament plants have also been added to the site to make the seasonal changes of the site more obvious and pleasant. After the amount of straw meets the construction needs, we will supply some nitrogen fixation grass. Some edible plants will be in a scattered manner to increase the interaction between people and the site. For example, in spring and summer, elderflower can be used to make shrimp and wine, and in autumn, the fruit can be used to make jam. Of course, a city farm will be planned and the plants could be chosen by the local community. Various community activity can take place in the park and especially the straw-built pavilion. From the section of the land, we see the current condition. It lacks human and animal activities on the land at this stage. Monoculture of the plants largely reduces the biodiversity, leaving only worms and insects visiting. With more facilities and buildings, it will also become a public park and a city farm for surrounding residents to make use of. And after our plan, this is what it will look like in the future. All the trees, bushes, and herbage will make it a perfect habitat for more animals to live in or visit.